Good morning. We're going to go ahead and get started on 2.2. Let me share my screen. 2.2. There we are. All right, so 2.2 is a continuation of linear functions. Today, we're going to talk about identifying if a function is linear or nonlinear. Then we're also going to be able to solve these linear equations symbolically, graphically, and numerically. We're also going to look at linear equations that have multiple variables. So it may have X and a Y or X, Y, and Z. I don't think we're going to get to X, Y, and Z today, but just know that that is possible. We're going to solve real world linear modeling problems with percents and motion and investment. So these are the application problems. And we're going to do that again in some real world problems where we're using, we're going to be identifying slope and interpreting that slope. So we're not only just identifying it, oh, what is it, but also what does it mean? And then kind of making some predictions and estimations, which is how we use linear equations in applications of life. So without further ado, let's get started. So a linear equation and a nonlinear equation, we know, we talked about this a bit in 2.1, what the difference is, but in general, the exponent is 1 in a linear case. So for linear equations, the exponent is always 1. Now remember, the problem is that we don't actually write that 1, so you may be confused. But if you don't see anything, anything other than a 1, then most likely that will be linear if there's other cases that are also in effect. So like we can't have any square roots, no square roots. No radicals in general. This means cube roots or quintic roots, any type of square root or any type of root we cannot have. So no square roots, no radicals, no absolute value. Someone in class said maybe it's just in that mx plus b form, or just mx or just b. These are your linear options. And I would second that and say, yeah, most likely that is going to be the case. So when we look and see if these are linear or nonlinear, I want you to pause the video and just try it on your own, A through D. Which do you think are linear or nonlinear? Play a little game and then come back and press play. All right, now that you've played that game and you are back, here we go. This one has an exponent larger than 1, therefore, or other than 1 rather. So therefore, this is non-linear. Okay, and actually, I can just tab over. Non-linear because that exponent is 3. For B, we have a square root symbol. Remember, we said we can't have any roots because that splits the x. And so this is non-linear because it contains a root. In C, if we use the distributive property, then what we end up with is 2x minus 8 equals -3. And this is kind of in that mx plus b form. So I would say that this is linear. And the exponent, of course, is a 1. And then D, we're going to say this is nonlinear because it has absolute value symbols. These straight lines mean absolute value. And that means that it's nonlinear. Okay. All right, moving on to the next concept, we have solving, symbolic solutions. So how do you solve an equation? If you have an equation, obviously you can use the reverse of PEMDAS. We talked about that a couple classes ago. And so to solve for A, we would add 4 to both sides to get x by itself. So I usually circle the x, circle the thing that I want by itself, and then I get rid of everything else that's on the same side of that. Okay, so when in doing that, you have x equals 12. Notice that -4 plus 4 is 0. So that's why we're able to just put a line through it. It sums to 0. That's called the addition property of equality. Okay, it doesn't change anything because we're doing it to both sides. And then when you're doing the inverse operation, it gets rid of it. So the same idea is here with B. Again, pause the video, try it on your own, and then you can press play and see what happens. So we're getting, we want the x to stay, we want the 7 to go. This is a +7, so we're gonna do the inverse operation and subtract 7, but we're gonna subtract 7 from both sides. And we get x equals 2. Inverse property of multiplication is division. So this is 3 times x. So that x is multiplied by the 3. We're going to divide by 3 in order to get x by itself in this case. And so remember that 3 divided by 3 is 1. So that leaves us with 1x equals 4. You can always check your work by plugging that number back into the original equation and seeing if it holds true. So 3 times 4 does equal 12. Here we have x divided by 5. So inverse operation means we're going to multiply by 5 on both sides. Remember that we have to do equality. So we have to keep it equal. Okay, multiplying by 5 on both sides. 5, that gives us 5 over 5, which is still 1. And so we have 1x equal 10. And check your work. 10 divided by 5 does equal 2. Perfect. That really important piece is to check your work. I used to I still do. I used to say, I love math because at the end of it, you can always check your work and make sure that you've done it correctly. Okay. All right, so now we're gonna have some more practice on solving equations, but we're gonna put multiple steps together. So this was that one situation where I explained like Mr. X had the girlfriend and the wife or whatever. So in this case, X is married to the -5 and has a side chick of 2. Get rid of the side chick first. Okay. And then divorce the wife. So we subtract 2 from both sides. You cannot add 2 because if you add 2, then 2 plus 2 makes 4. But because we have 2 and we take away 2, we end up with 0. So that's how you get rid of it. Make sure you do the opposite operation. A lot of people get confused right there. So don't let that confuse you. Okay, then you divide by -5, I'm sorry. Note that -5 divided by -5 is still 1. So we have 1x equals -2. Of course, you should check because sometimes these questions do give you extraneous solutions. So we'll talk about those in a bit as well. But that x is what we just solved for. So instead, replace the x with the -2 that we said it's equal to and see if it's true. Put a little question mark over your equal sign. So we have -5 times -2, which is +10. And 10 plus 2 makes 12. The same value on both sides means that it works. Solution checks out. Okay, let's solve this next one. Again, stop the video, try it on your own, and then come back with it. 4D minus 4 equals D. We have D's on both sides. The first thing I would do is to simplify that and subtract those 4 D's over to the other side. Or subtract the 1D. Either way, it doesn't matter. We're gonna do both actually, since I've already said it. I'll subtract 4D. Then we get -4 equals -3D. Let's see what the other side does. We have 3D minus 4 equals 0. Add 4 to both sides. We get 3D equals 4. Here, in my case, I'm ready to just divide by -3 so I can get the D by itself. And I get 4/3 because negative divided by negative is a positive. On this other side, divide by 3. Again, we get D equals 4/3. So notice that it didn't matter which one you did first. You still get the same answer. But as always, check your answer, check your work. Get that original equation and substitute that value in. We have 4 times 4/3 minus 4. Does that equal 4/3? Let's see. The calculator will allow you to do this fraction. And we can talk about that in class. But when you do 4 times 4/3, you get 16/3. And if you subtract 4 over 4, I'm sorry, if you subtract 4, then you are good to go. Okay, sorry about that. So basically what I was saying was you can do this operation in your calculator and see if it actually equals 4/3. If you know how to do that, then that's perfect. If not, then there's no worries. I'll show you how to do it by hand. 4 times 4/3 is just 16/3. Okay, 16/3 minus 4. Well, I want to write 4 as a fraction of 3. So that's 12/3 because 12 divided by 3 is 4. So that leaves me with 4/3. And that tells me that, yes, that is my answer that checks out. All right. If you don't understand it, just slow that down and stop it and pause it and try to make sure you understand how to do fraction operations because that is going to be prevalent all throughout the semester. Okay. Solve the equation symbolically again. This time we have, again, variables on both sides, but also other things as well. So we're going to try to simplify this algebra first. So the first thing we'll do is use the distributive property here, and we get 3x minus 12 equals x plus 1. Then we'll combine like terms on either side. So let's start moving the x. One strategy is to always move the one that's the least amount. So we have 3x over here and we have 1x over here. So subtract the 1x. And then you end up with your 2x. That's how you work with positive numbers. If you don't like really to work with negatives, then that's one way to avoid working with negatives. All right, so we have 2x minus 12 equals 1 because these x's went away. Not went away, but they sum to 0. Okay, then we're in our normal situation where we're getting rid of the girlfriend, divorcing the wife. Add 12 to both sides. We get 2x equals 13 and divide by 2. X equals 6.5 or x equals 13/2. Check your work by rewriting the original equation and just replacing that x with 13/2 and seeing if it's actually true. Again, you can use a calculator to perform this arithmetic. And you'll see that 15/2 does indeed equal 15/2. Okay. There's a calc that you can type this into the calculator and it will tell you exactly how you do that. I'm thinking I should actually share that calculator strategy with you real quick. So bear with me as I pull up my calculator. Okay. Uh-oh. Hey, let's see. I'm going to pull up the TI-84. I'm going to show y'all how to do this. All right, so first you want to clear your calculator. That's second plus 712. Push enter. Okay. There's a couple different ways to do this. I'm going to try one way that I don't actually know if it'll work and just see if it works, and that'll be great because we'll both learn something. So the problem was 3 times x, which we now know is to 13/2. So we're going to plug in 13/2 where the x was. I like to put it in as a fraction. You can use a division bar if you like, but then you have to worry about all these parentheses and things. So I'm going to say alpha y equals, this gives me n over d. That's numerator over denominator. It's basically allowing me to type in a fraction. 13/2. Okay. Let me get the problem right before I move on. So it's 3 parentheses x minus 4 parentheses equals x plus 1. Okay, so minus 4 close parentheses, and then you're going to have to say enter. Okay, and that's going to give me 15/2. Now do the right hand side, which was x plus 1. So we're just going to say 13/2. I'm alpha y equals numerator over denominator 13/2 plus 1. Perfect. So the left and the right equal each other. That means that our answer is correct. So that worked. That's legit. I think we can just stop right there and we'll use that as our strategy. Okay. Let's go back to 2.2 and continue. Uh-oh. Uh-oh. So we said we use a calculator and boom, that is good. It checks. Okay. Example 6. We have symbolic equation that has fractions in it. So people get really scared of this one. So let's take this one slow and let's make sure we all understand it. Eliminating the fractions at the first step can really make the problem simpler. So the first thing we want to do is I would multiply by 6. Somebody say, why would you multiply by 6? Well, 3 goes into 6 and 2 goes into 6. That's called the least common denominator. And so that way we will have no fractions left if we multiply by 6, because 6 is going to basically scale up our entire equation, but it's not going to change the equation. So if we multiply everything by 6 on the left and the right, then by doing this first one, the 6 goes into this first part and then it goes into the second part. So 6 times x plus 1 over 3. Well, the 6 will cancel with the 3, and we'll end up with having 2 times x plus 1. The 6 also is getting multiplied by 1/2, and we'll end up with 3. And 6 gets multiplied by 2 and we get 12. So this is where we end when we multiply everything by 6. Notice that we have no more fractions left, because 6 divided by 3 just makes 2. 6 divided by 2 just makes 3. And that's how we get this next line. Now that we have that, we can use the rest of our strategies to solve these. Use the distributive property and then combine like terms and solve for x. So distributive property gives us 2x plus 2 minus 3 equals 12x. The 2 minus 3 makes -1, so that's where that comes from. Now we have 2x minus 1 equal 12x. So subtract the 2x from both sides because we need the x's together. And we have -1 equal 10x. Now we have multiply by 10, so we need to divide by 10 on both sides. Okay. And we get x equals -1/10. We need to check our work. So rewrite the original question, and wherever there's an x, substitute a -1/10. Use the calculator and let's see if it's actually true. So this one may be difficult to type in, so I'm going to show you on the calculator how you can do that. Okay. Parentheses. Actually, I want to type all of this in as a fraction. So second y equals, okay, and in the top parentheses, then we're going to put another fraction in, which is our -1/10. Okay, plus 1 over 3. Okay, minus 1/2. Let me make sure I typed that in correctly. That's correct. Push enter. Then on the right-hand side, we had 2 times x. So we just put 2 times, no, there's no undo button. There we go. If you push enter, it'll bring it back. So 2 times numerator over denominator, -1/10. Notice you got to get out of the fraction to close it. There we go. They both equal 1 fit, a -1 fit, so that means we did it correctly. Checking your work can be tedious, but it's really important because if you check your work, you know you got the right answer. All right, let's go and move on. So now we're just going to generalize this thing and say, hey, what do you do to solve equations? Like, what are the steps? And they are as follows. In general, use these steps to solve one variable linear equations. First, simplify the equation by removing parentheses and fractions and combining like terms. And you only want to work on one side of the equation at a time so that you can simplify it and not be all confused. So let's say this was our equation. Over here, we would distributive property. Okay. And then on the next side, we would actually then see, oh, these both got y's. So these are like terms. 5 minus 2 makes 3y. And now we have a simplified situation. Okay. Add or subtract the same terms from both sides to move all the variables on one side. Notice that I like to move the smaller amount so that we don't have to deal with negatives. Okay. So I kind of would move the 3y. And we end up with 2y minus 5 equals 7. Simplify it. So then we move the 5 to the other side. That's the getting rid of the girlfriend part. And you have 2y equals 12. Last step, multiply, divide by that same non-zero number to make the number in the variable term +1. So basically we want to have just 1y instead of 2y. So we're going to divide by 2 and we get 1y equals 6. That's not all the steps though. First, simplify, remove parentheses, combine like terms, do one side at a time, just so you can simplify your equation and be working with something easier. Then number 2, add or subtract to move all the variables on one side, all the constants on one side. Then you have that simplified situation where then you can go ahead and rectify the marriage. In general, after you're done with that, you have to check your work. So this is how you check your work. Rewrite the original equation, replace that variable with the value that you found, and see if it's true. See if they hold true. If you get that same number on both sides, then yes, that is a solution. That means your solution checks out. Okay, example 8. We're going to do this one. Notice that it has 2 variables. That was that objective that said we're going to learn how to solve equations with 2 variables. You cannot solve an equation that has 2 variables for a number. Like you can't do that because you don't have enough information. Instead, you can solve for a variable. So in this case, we have 4x minus 7y equal 2. It says solve for y. So that means get y by itself. Everything else has to go. Gotta go, gotta go. Okay. That was kind of, the y stays. The minus 7 gotta go. And the 4x gotta go. So the first thing you would do is move the 4x to the other side. Notice that this is not going to be 2. A lot of people say, oh, I can subtract these. No, you can't. That 2 and that 4x are not common terms. So instead, you need to just write them side by side. Convention says put the x in front of the constant. So like mx plus b, put it in that order. Then we almost there. We got to get rid of the 7. So now we're going to divide by 7. You got to divide everything by 7. So you end up with y equals 4x. I'm sorry, negative 4x divided by negative 7 and 2 divided by negative 7. When you simplify that, you put the values on top of each other as a fraction and the x goes on side of it. This is your slope. This is your y-intercept. Okay. Now, there are different types of equations when you do this. Oh, I'm sorry. Let me go back. We didn't check our work because we can't. In this case, you don't have a value that you go back and substitute in. You could put this in for y and then see that it has the same value on both sides. But that's not what we're going to do. We're just going to accept the fact that we did this correctly. Now, 3 different types of equations in one variable. So you have contradictions, identities, and conditionals. Conditionals are where like there's at least one solution. An identity is where you end up with the same number or equal the same number. Well, that's always true. So that's every solution, every value is a solution. No matter what you put in, every value is a solution. A contradiction is where you end up with a false statement. It's no solution. Not true. Okay. So let's solve these. I would pause my video if I were you and just try to do it myself and see which one I can figure out based on the knowledge that I have. Okay. Let's do this together. Or you just pause the video and now you unpaused it. Distributive property. Uh-oh. 2x plus 6 equals 5x minus 4. Simplify, move the 2x's to the other side. You get 6 equals 3x plus minus 4. Add 4 to both sides. 3x equals 10. Divide by 3. X equals 10 divided by 3. And you can leave that just like that. You can substitute it in to make sure you got it correctly, but this is called a conditional equation because it does have one solution. So there it is. Okay. Equation B, we're gonna subtract 2x from both sides. Uh-oh, they disappear. You end up with 3 equal -1. When does 3 equal -1? Never. 3 will never equal -1. Therefore, this is a contradiction. There are no solutions. Next equation, we're going to do the distributive property once more and simplify. We see that these two are common terms. So we get 2x plus 3 equals 2x plus 3. Well, that's pretty much true. So if we subtract 2x from both sides, we end up with 3 equals 3. 3 always equals 3. This means that this is an identity because it's always true. Every value is a solution. Okay, example 11. Where is the graph? F of x increasing or decreasing? So f of x is this blue one. Maybe it look like it's decreasing the whole time. It don't look like it's ever increasing. So in this case, decreasing, we would say negative infinity to positive infinity, but increasing is never. But a green one is just the opposite. It's increasing from negative infinity to positive infinity, and it's never decreasing. All right, it says find f of -2. So that means go to this blue one and look where x is -2, -1, -2 right here. So where is my y value? Well, it's still right here. It didn't go up or down. Therefore, it's equal to 0. F of -2 equals 0. Okay. Example 11. Use the intersection of the graph to graph this equation. We got a left and a right. So we're basically trying to graph both of those that sides of the equation separately. So we graph the first one, that's the blue one. We graph the right side, that's the green one. And we say, well, where do they intersect? They intersect right here at 1, 2, -1, -2, -2. And that's where the graphs are equal to each other. So that is the value at which they have common solution. So that's where x equal to right there. So that would be our solution. All right, using the graph, we can just answer these questions. This is just something that we've already been doing. We know that when the numbers inside of the parentheses, that means x equals -4. So just go look at -4, 1, 2, -1, -2, -3, -4 is right here at 2. So f of -4 equals 2. It says find where the function value is equal to -4. So we're actually going to go and look for y equal -4 and find out the x value. That's right here going up. That looks like it's at -1. So -1, -4. So what is the X value when Y is -4? It's -1. It says, what is the X value when Y is 0? Well, I don't see Y being 0 on this graph, so I really can't see it right now. And it says use the graph to answer the following. So it looked like it's gonna happen somewhere down here. I can't really tell. Oh my God, I'm looking for where X is equal to 0. I'm so sorry, I did that backwards. We are looking for where Y is 0. So Y is 0 on the X axis, and that happens right here at -3. My bad. All right, the application problems, and we are done with 2.2. Lung cancer accounted for 15.8% of the US cancer deaths in 2007. Wow, that's horrible. Find the formula f of X for the function that computes the number of people who die from lung cancer among X people who died of cancer. First off, this is super insensitive question, so I apologize if anybody has been dealing with a death due to cancer. Definitely, this is applications, and this is how math is used. So when it's written as a percent, you never put that percent into your into your equation. You have to change a percent to a decimal. And remember how we do that is just we move the decimal place over twice. So it's 0.158 instead of 15.8. And so 15.8% of X amount of people. So of means multiply by the number of people X. So that is our equation. Given that approximately 229,000 people died of lung cancer, how many people have died of cancer in general? So X is the number of people who died of cancer in general. F of X is the people who died of lung cancer. So F of X is died of lung cancer. The X is just who died of cancer in general. So we're going to plug in what we know. We know the number of people who died of lung cancer. So we put that as F of X. And then we don't know X. So we're going to solve for X. So in this case, we'll divide by 0.158 on both sides. Uh-oh. For some reason, I'm frozen. Just a second. Okay, divide by 0.158. And we have X equals 1,449,367 people died of cancer in 2007. Wow, 1 million, over almost 1.5 million people died of cancer. And you know that number had to be bigger than 229,000 because 229,000 only represents about 16% of the people who died in general from cancer. In 2 hours, an athlete traveled 16.1 miles by running at a 7 mile per hour, and then at 10 miles per hour. So basically the first hour he was running slower, and the second hour he was kind of like, okay, well, let me hurry up. It says, how long did the athlete run at each speed? Well, we don't really know. So we have to figure out that with an equation. Took 2 hours. We're gonna let T be the time that he ran 7 hours. And then that means that the other time, 2 minus T is the amount of time that he ran for 10 hours. 10 miles per hour. So let's make this make sense real quick. If the guy ran 2 hours, or the girl ran 2 hours total. Well, for some time, we don't know, ran 7 miles per hour. The rest of the time, how do you say the rest of the time? Well, you say the 2 hours minus the time that they ran 7 miles per hour, and that would leave us with the other 10 miles per hour. So these two go together and these two go together. Okay. Distance equals rate times time. So We have the distance of 7 miles per hour plus a distance of 10 miles per hour equaling 16.1 miles per hour total for 2 hours. So 7 times t plus 10 times 2 minus t equals 16.1. Use your distributive property, and you end up with this. Combine like terms, 7 minus 10 is -3. T plus 20 equals 16.1. Subtract 20 from both sides. 3t equals -3.9. Divide by -3, we get t equal 1.3. So that means he ran 7 miles per hour for 1.3 hours. That means he ran 10 miles per hour for 0.7 miles per hour. I'm sorry, for 0.7 hours total. Okay, again, we can talk about this in class, but that's the gist. Stop it and pause it and try to make sense of it on your own. We'll talk about this in class on Wednesday. All righty.